Hey guys, in this section there's not going to be any questions, it's just a reference for you in terms of what the unit circle is and how to use it. It's a very useful tool for finding exact values, and we'll get into it here. So unit circle, but basically unit means one. So what does that mean? Well, if I think about our principal arm, that is 1 unit long, and imagine this principal arm going around the circle. Every terminal arm that we have would be a distance of 1, no matter what, to a spot that is on that circle. So what does that mean? Well, basically, if we keep that as 1, we have a point X and Y that's created at this spot right here. So Y is the value that the dot is above the x-axis in this case, and x is the distance to the right of the origin for that point. So that makes up our point x and y. Now, what happens as that angle gets bigger? So let's suppose, use a different color here. Let's suppose we were here. What happens to x and y? Well, notice that the y value is now larger than it was. What about the x value? Well, the x value is quite a bit smaller than it was, right? For the first angle, it was this distance. Now it's just this distance here. So as we go around the unit circle, the x's and y values change. Why is that important? Well, let's go back to the original one that we had here. The sine and cos values are of the angle. Sine is opposite y over hypotenuse, which is 1. So sine is y over 1. That's what we have written over here. Y over the radius, but radius is 1. So sine is just y. So that point that we're given here, I know it's at x and sine of the angle. Great. So what does that mean for the x value? Well, let's think about that. Well, cos in this case is adjacent to the angle, right? The angle's right here. Adjacent to the angle over hypotenuse, which is 1. So cos of the angle is x over 1, which is just x. So that x coordinate is cos. So any given point as we go around the unit circle, the x's are cos, the sine values are y, as you can see in this table over here on the left side, because the radius is always 1 for the unit circle. It's the idea of why we made a unit circle, so it's easier to work with. So sine are the y values, cos are the x values, and tan, well, how do I get y over x? Well, you might remember the identity. Sine over cos is equal to tan. Well, if sine is y and cos is x, well, it's y over x. And the bottom, the reciprocals of the primary ratios, the ones that are at the bottom, are just the reciprocals of them. So cosecant is the reciprocal of sine. So if sine was y, well, it's 1 over y. Cosecant is reciprocal of cos, 1 over x. And cotangent is the reciprocal of tan, so x over y. So as long as I have x and y points, I can get any of the primary ratios and the reciprocals no matter what. So how do those work? What are those values? Well, those are what we're going to use this unit circle for. Now the unit circle is just drawn on the x and y axis. And because each of these lines, so this line here is 1, this line here is 1, this line here is 1, all we're going to pay attention to is the x and y values that are associated with it. So I'm going to fix this, make it look nicer. So let's start with the first one. First one, we have the terminal arm going along here. What is the point that's at the end of this? Well, that's going to be at 1 and 0. So what does that mean? Well, that means I know what sine's going to be. Sine of 0, right? This would be angle 0. We haven't even gone around the circle at all. It's at its starting spot. Sine of 0, that's y value, 0. Put that in my calculator, I'm going to get 0. Cos of angle 0, well, that's the x value, that's 1. Put that in your calculator and test it if you want. Tan of 0, well, that's sine over cos, 0 divided by 1, 0. And I can find out what cosecant's going to be, secant and cotangent, just by taking the reciprocal of each. Reciprocal of 0 is undefined. Reciprocal of 1 for secant is also 1. And reciprocal of 0 for tan to get cotangent is undefined as well. So that's kind of the idea behind getting all 6 of our ratios as long as I have the points around the outside. So let's go through how do I get the points around the outside for this. So basically what we do is we think about the related acute angle always with the x-axis. So this one here, the related acute angle is 30 degrees. Or another way that we can write that is pi over 6. The points that we get for pi over 6 are 30 degrees. If you look at your special triangle, your 30, 60, 90 triangle, you're going to find out that it is root 3 over 2 and 1 over 2. So where else might I have 30 degree related acute angle? We're going to have another one over here. Right, this is also 30 degrees, the related acute angle. The actual principal angle, the angle that we'd have going around like to here, would be 150 degrees. But keep in mind what I know, this is pi, so I'm less pi over 6 or less 30 degrees. So I'm going to have, use purple for that one. We're going to have 5 pi over 6 for that one because I've lost the pi over 6, right? We're less a pi over 6 of the halfway around the circle. So what are the x and y coordinates associated with it? Well, what you're going to find is it's exactly the same as what we have for the first one. Pi over 6 always has those same x and y coordinates. The only difference is our points are to the left as opposed to the right. And when they're to the left, you know the x value's got to be negative. Our y value is still positive because it's above the x-axis. Right? It's up here. So the y value is still positive, but the x is negative in this case. So the 2 points are negative pi over root 3 over 2 and a half. So let's keep going. Where else am I going to have 30 degrees? Well, it'll be this spot right here. It would also be 30 degrees, related acute angle. So what is that angle that's associated with it? So if pi is here, I've added another pi over 6 or 30 degrees to it. So I'm going to have 7 pi over 6. What are the points associated with it? Well, it's still going to be root 3 over 2 and a half. However, we're to the left, so x is negative, and down, y is negative. And lastly, we're going to have one more, this quadrant here. That has a related acute angle of 30 degrees here as well. Remember, related acute angle is always with the x-axis. So if it's 2 pi all the way around here, but I'm not quite all the way around. If I think about the angle that I'm working with, I've gone all the way around and I've stopped 30 degrees short. So what does that mean? That means that the angle that we must have here is 11 pi over 6, right? We're just a pi over 6 short of 12 pi over 6, which is 2 pi. What are the points that are associated with it for x and y? Well, it's going to be root 3 over 2 and a half. But which one's going to be negative? Well, we're to the right and down. To the right, x is positive, but down, y is negative. So those are the x and y points associated with them. So I can find out the sine, all the y values, the cos, all the x values, or the tan, we'll divide y divided by x values for each of these angles. Pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. One other thing to keep in mind is notice which ratios are positive and negative. Remember that cast rule. All are positive in that first quadrant, both these. Only sine is positive in the second quadrant. Only the y values are positive in the second quadrant. Right, sine is y. Tan. Well, tan is sine divided by cos. Now in this case, our tan values will end up being positive. Well, how do I get tan from these? Well, remember, we're dividing. Y divided by x. Divide two negatives, I get a positive. So that's why tan is positive there. And cos is positive in the last quadrant, so notice that the x values are positive because cos relates to the x values. So let's go through the other ones here, and you'll see the same thing apply to all of them. Next one that we'll look at, I'll use pink. So the next angle that we have is 45. That's pi over 4. Its points are root 2 over 2 and root 2 over 2. So same. So pi over 4s are always easy ones to work with. We'll keep going. Where else is pi over 4 or 45 degrees? Well, it'll be this section right here. So this one will be 3 pi over 4. What are the points associated with it? Well, root 2 over 2. But what's negative? The x values are negative in this case, right? Quadrant 2, the x values, because we're to the left. To the left and up, so x is negative, y is positive. Keep going. Next one that has a related acute angle of 45 or pi over 4 is down here. So what are we at? Pi plus pi over 4, which is 5 pi over 4. Its points, root 2 over 2. In this case, both are negative because it's to the left and down. And then the last one here, you can imagine what we're at, 2 pi. You can think of that as being like 8 pi over 4, because all these 45 degree related acute angles are over 4. So one less than that, we're going to have 7 pi over 4. What are the x and y values associated with it? Root 2 over 2, which is going to be negative. In this case, the y values are negative because they fall to the right and down. So that's those ones, and I'm just going to take off these numbers in the center here so it doesn't get too crowded. And we'll do the last one here. Maybe we'll choose dark green. These ones here are pi over 3. That's 60 degree angle from here to here. What are the points that are it? Well, it's 1 over 2 and root 3 over 2. Both are positive because it's to the right and up. Next one, we have 60 degrees right here. So it is 2 pi over 3. What are the points? Well, they're the same, 1 over 2 and root 3 over 2. But the x values are negative in quadrant 2. We have another one down here. What is this one? Well, one way that we can figure out the angles is I know that the first one here, I'm darkening it in, is pi over 3. Next one, this will be 2 pi over 3. The next one, 3 pi over 3. Right, 3 pi over 3 is just pi. So then as I continue, we're going to have 4 pi over 3. And its points will remain the same. We're going to have 1 over 2 and root 3 over 2. And both are going to be negative because we're in quadrant 3. We're to the left and down. Left, the negatives, or the x is negative, and down the y is negative. And then finally the last one. So that's 4 pi over 3. Next one's got to be right here, 5 pi over 3. Or you might say, well, what's missing here? This is 2 pi, but I'm less pi over 3. Regardless how you look at it, it's 5 pi over 3. And its points, 1 over 2, root 3 over 2, and which ones are negative? The y value is negative. So that's the idea behind the unit circle, or that is the unit circle. Now, why is it useful? It allows us to find out exact values of sine, cos, tan, secant, cosecant, and cotangent, no matter what, as long as I have these, because I can get my x and y values. Now, the unit circle is a little bit special as well because it allows us to find out angles like 90 degrees right at the top. Right at the top is going to be 0 and 1. How about to the left? Well, I know what that's going to be, -1 and 0. Or just the x and y values. And how about 1 down? Remember, unit circles, we're dealing with 1. This one's going to be 0 and -1. So I can get all of these different angles. It looks really messy on here, but that's the idea behind the unit circle. You can get sine, cos, and tan, as well as the reciprocals from each of these angles, no matter what. Now, what I do is I like to simplify it by just memorizing this first quadrant here. Because if I memorize this first quadrant here, I'm going to know all of my sine, cos, tan values and their reciprocals. As well, all I need to do is figure out the sine, and I put that in front. Because we showed that all of the x and y values stay the same. It's only the signs that change. So how do I do that? Basically, this is going to help you a little bit. But on tests or quizzes, a lot of times you just write out this. And we fill in what we know. I know that right along here is 1 and 0. I know the 90 degrees up at the top, or pi over 2, is 0 and 1. I know to the left, 180 degrees is going to be at -1 and 0. And I know down is going to be at 0 and -1. Right, those ones are easy. If I want sine of 0, for example, I would know it's 0. Sine of 90 is 1. Sine of 180 is 0. Sine of 270 is -1. Cos, I can get the x values. Tan, I can divide y divided by x. And I can get the reciprocals of any of those if we want. Now, how do I remember what the angles are going to be? Well, we start with the smallest one. Maybe I'll use a different color here. It's pi over 6, so smallest denomination. Pi over 4. And pi over 3. I open up my brackets for my coordinates of x and y. And the way that we do is we just say 1, 2, 3, and all of those over 2. And then square root the top. So square root of 1 is 1. Square root of 2 is root 2. Square root of 3. And then I do the same thing, but in reverse for the y values. 1, 2, 3, and all of those over 2. And I square root each of them. So square root of 1 is 1, root 2, and root 2. That gives my x and y values for that quadrant. Only thing that will change is the signs that are in front of them, depending on what quadrant we have, but we have our angles associated with each of them. Because remember in that special triangle that we had at the top, all of my purple angles had a denominator of 6. Those are all the ones with the related acute angle of 30 degrees. All of my related acute angle of 45 degrees all had pi over 4. Right? The denominator gives away all kinds of information. And all the ones that had a related acute angle of 60 degrees had pi over 3 as their denominator. So the denominator gives away all kinds of information. So let's go through a couple of examples using this consolidated circle to figure out what our answers are going to be. So this one here, sine, well, sine is y. So I'm looking for 0 degrees. Well, that's right along the x-axis here. I'm looking for the y associated with that. Well, if I look at it, I see that it's at 0. So this is equal to 0. I don't have to worry about positive or negative for those because, well, 0 is 0. How about cos of 180 degrees? Well, 180 degrees is right across here. Cos are the x values, so I know that that's got to be -1. How about secant of 180 degrees, or pi? Well, secant is the reciprocal of cos, so that's 1 over x then. So whatever I get for the x value, I'm going to put on the bottom. So let's find out, where is 180 degrees? Well, we've already got that one on there. 1 over x, well, the x value is -1, so it's going to be 1 over -1, which is -1. Keep going along. 4, 2 pi over 3. Well, I already know what my related acute angle is going to be because the denominator always gives it away. I have 3 on the bottom. I know that it's going to be a 60-degree related acute angle. But if we're not sure, we want to check. I know that we are 2/3 of the way to pi. So pi would be over here. So if we're 2/3 of the way to pi, I know I'm in this section over here. I know that the related acute angle has got to be pi over 3. The denominator gives that away, right? If this is 2 pi over 3, and I add pi over 3, that's how I get pi. And it's 3 pi over 3, which is then just pi. So what I'm going to do is use CAST rule. C-A-S-T. I know sine is positive here. I'm looking for the y values of pi over 3. So it's going to be positive, but I'm looking for pi over 3 and the y values. So that's root 3 over 2 from our consolidated circle. So it's positive root 3 over 2 is the exact value for sine 2 pi over 3. Keep going here. Cos negative pi over 3. Like pi over 3. 3 gives me some information as to what my related acute angle is going to be. I know it's going to be 60 degrees or pi over 3. So negative means we're going in the clockwise direction. So pi over 3. So first things first, I know the CAST rule, C-A-S-T, says that cos is going to be positive in that quadrant. So I know the answer is positive something. I don't know what that something is, but let's go through it. Cos, I'm looking for the x values of pi over 3. So I'm going to go up to my consolidated circle. I'm going to find pi over 3, and the x value is 1 over 2. So this is positive 1 over 2. That's it. That's how we get our exact values. Same thing. You're going to see it kind of gets repetitive. If you get the idea, you can skip it. But I'll continue for those of you still interested. Next one, we're looking for cosecant. 330. So I know that that's in this quadrant here because we're 30 degrees short, or pi over 6 degrees short. That is 30 degrees of a full circle, right? 360 degrees is a full circle. So CAST rule says that only cos and its reciprocal is positive in that quadrant. So we're looking at cosecant, which is the reciprocal of sine. So I know it's going to be negative something. I don't know exactly what, but I know it's going to be negative something. I'm looking at cosecant. That's 1 over y. So it's going to be negative 1 over something. Well, let's find out what y is for pi over 6. So pi over 6, my y value is half. So 1 over a half. 1 divided by a half is just negative 2. If you're not sure, well, 1 divided by a half, remember when you're dividing by a fraction, it's the same thing as multiplying by its reciprocal. Works out to be 2. But it's negative because of what quadrant it's in. But that's just the algebra behind it, in case you forgot. Keep going along. So we're getting these exact values. Tan 225. So I know that we are 90, 180, 270. Well, that's too much. So it's in this quadrant here. So if it's 180 and this is 225, well, the difference between that is 45, or pi over 4. So if I'm to solve this one, tan is positive in that quadrant, right? CAST rule, C-A-S-T. We're going to positive is my answer no matter what. Now I'm looking for tan of pi over 4. Well, what is tan? Tan was y over x. So let's find out what the y value is. Let's find out what the x value is at that related acute angle of pi over 4. Well, they are root 2 over 2 and root 2 over 2. So I'm going to divide those ones together. So I'm going to take these off. It is root 2 over 2 divided by root 2 over 2. Same on top as on the bottom, so I know when I'm dividing those, I'm going to get positive 1. Cotangent, negative 5 pi over 6. That 6 tells me my related acute angle is going to be pi over 6. Denominator gives it away. So let's test it out here. It's negative 5 pi over 6, so we're 5/6 of the way to pi. Whoops. So this will be pi here, but I'm only 5/6 of the way there. So I've got to be in this quadrant here with a related acute angle of pi over 6. Because remember, if it's 5 pi over 6 here, or negative 5 pi over 6, I guess, and this will be pi here, we got to find the difference between those, and that's just that pi over 6. So, first things first, cast rule. Let's figure out what sign our answer is going to be. Now, tan is only positive in that quadrant. Cotangent is the reciprocal of tan, so I know it's going to be positive something. Next, I'm looking for cotangent. Well, cotangent is x over y, right? Reciprocal of tan. Tan was y over x, so cotangent is reciprocal of that. So I need to find out what x and y are for pi over 6 and divide them. So let's go up to our consolidated circle. Pi over 6, I see it there. My x value is root 3 over 2 divided by 1 over 2. Do the algebra behind that one. You can divide it or multiply by the reciprocal of half, which is 2. You're going to end up with root 3. Positive root 3, right? Positive because we talked about that earlier, but root 3. Same goes for the next one over here. Cosecant, same angle. I'll draw it out again here just so we get the idea. We had pi over 6, right? Denominator gives it away. We're going in this direction, but what matters is where we end up. CAST, tan is positive in that quadrant. We're looking for cosecant, which is not a reciprocal of tan, so I know it's going to be negative something. Cosecant, in terms of what it is, it's 1 over y, because sine is y, and cosecant's the reciprocal of that. So I need to find out what y is for the related acute angle pi over 6. So pi over 6, we did this earlier, but it's 1 over 2. So our answer is negative 1 over 1 over 2, which works out to be negative 2. That's the exact value for cosecant negative 5 pi over 6. And last one here, sine 2 pi over 3, we're 2/3 of the way to pi. So if I draw it out, 2/3 of the way to pi will be somewhere around here. The denominator is 3, so that tells me a lot about my related acute angle, because if it's 2 pi over 3 here, pi is here. Well, if I added these two together, I'm going to be 2 pi over 3 plus pi over 3 gives me 3 pi over 3, or just pi. Regardless, I'm looking for sine, so I'm looking for CAST. Sine is positive in that quadrant. We're looking for sine, so our answer is going to be positive something. So sine are the y values, so I'm looking for the sine y values for pi over 3. So I'm going to go up to pi over 3 and see what the y value is. I see that it's root 3 over 2. So I'm going to put that in. That's going to be my answer. Positive root 3 over 2. That's the exact value of sine 2 pi over 3. So that's kind of the idea behind the unit circle if you had forgotten, or how to find exact values for them. I know it looks a little messy here, but as long as we can draw that consolidated circle here, you can really solve exact values for any of our angles so far. So that's that. If you have any questions, let me know.